In this video, we will continue exercise 10.2, chapter 10, circles. So before this, required previous knowledge is about understanding of theorem 10.1, that is tangent at any point on the circle is perpendicular to the radius through point of contact, and theorem 10.2, that is length of tangents drawn from external point to a circle are of equal measure, and must familiar with the Pythagoras theorem, supplementary angles and complementary angles. So now let's begin with question number 9. So in the question number 9, you can see on the screen we are given a figure in which xy and x dash y dash are two parallel tangents to a circle with center O, and another tangent AB with point of contact C intersecting xy at point A and x dash y dash at point B. Prove that AOB equals to 90 degree. So you can see on the screen in the figure we are given two parallel tangents xy and x dash y dash, and another third tangent, that is AB, that touches the circle at point of contact C and intersecting the tangent xy at point A and x dash y dash at point B. So now we need to prove this angle AOB is equals to 90 degree, that is 4 plus 5 equals to 90 degree. So we are given a circle with center O has three tangents, that is xy, x dash y dash and AB at point of contacts P, Q and C respectively, and xy parallel to x dash y dash. So now we need to prove that angle AOB equals to 90 degree. So हमें prove करना है angle AOB equals to 90 degree. So you can see in the figure, first try to understand the concept. Here take pair of two triangles, you can see, or you can take two triangles APO or ACO, or another pair it may be BQO or BCO. So आप ये दो पेयर भी ले सकते हैं और आप सीधे से ये पेयर भी ले सकते हैं. So in triangle APO and ACO, you can see here AP and AC are tangents drawn from exterior point to the circle. So length of AP will be equals to length of AC. Similarly, OP and OC are the radii of circles. So these two will be equal, and OA is common to both triangles. So these two triangles will be congruent by side, or we can prove these two triangles congruent by using RHS rule also. You can see here radius is perpendicular to tangent at point of contact. So angle 1 is right angle, and similarly angle 2 is right angle. So angle 1 equals to angle 2 equal to 90 degree each. AP equals to AC, that is length of tangents, and AO, or you can say OA, is common to both. So side opposite to right angle will be hypotenuse. So you can see OA is the hypotenuse of triangle APO as well as ACO. So these two triangles are also congruent by the rule RHS, right angle hypotenuse side. So we can prove these two triangles congruent by two methods, by side or by using RHS. So here first of all we have to do the construction, that is join OC. So now in the proof part, take triangle OPA, you can see here this triangle, and OCA this triangle. So now in triangle OPA and OCA, AP equals to AC, that is tangent drawn from an exterior point to the circle. OA equals to OA, that is common, and angle 1 equals to angle 2, that is 90 degree each, as OP is perpendicular to XY and OC is perpendicular to AB. These are the, as we know that radius is perpendicular to tangent at point of contact, therefore this 1 and angle 2 are 90 degree each. So therefore these two triangle OPA is congruent to triangle OCA, or we can say these two triangles are congruent to each other by using right angle hypotenuse side congruency rule. So therefore we can say angle 3 equals to 4, that is by CPCT. आप देख सकते हैं 3 equals to 4 कहाँ है, 3 is here and 4 is here. So these 3 and 4 are congruent to each other, or we can say both are equal by using CPCT, that is corresponding parts of congruent triangle. Similarly, we can prove that angle 5 equals to angle 6 are equal to each other. So similarly we can see 5 equals to 6. So as POQ is diameter, that is a straight line, so we can say angle 3 plus 4 plus 5 plus 6 equals to 180 degree. Now we are not required angle 3, we are required only 4 and 5, that is angle AOB. So 3 will be replaced with angle 4, and similarly 6 will be replaced with 5. So twice of angle 4 plus twice of angle 5 equals to 180 degree. And now 2 can be taken as common. So 2 into angle 4 plus 5 equals to 180 degree. So angle 4 plus 5 equals to 180 upon 2, that is 90 degree. So angle AOB equals to 90 degree, that is we are required to prove. So AOB equals to 90 हमें मिल जाता है, जैसा कि आप हमें प्रूव करना था. आप देख सकते हैं angle AOB, that is angle 4 plus 5 equals to 90 degree. This is all about question number 9. So now proceed for question number 10. that is prove that the angle between two tangents drawn from external point to a circle is supplementary to the angle subtended by the line segment joining the point of contact at the center. So हमें prove करना है कि जो angle between two tangents है means this angle, and angle made by the line segment joining the point of contact at the center means we are to prove that central angle, that is AOB, is supplementary with angle APB. मीन्स इन दोनों एंगल्स का सम कितना है 180. सो याद रखेंगे C दैट इज कॉम्प्लीमेंट्री, C इक्वल्स टू 90 डिग्री. जब भी दो एंगल का सम क्या हो 90 डिग्री हो, देन वी विल से दिस टू एंगल्स आर complementary to each other. And if we are talking about the supplementary angle, the sum of two angles will be 180 degree. So we are to prove here angle AOB plus APB equals to 180 degree. हमें prove करना है supplementary. So we are to prove this, that sum of these two angles AOB plus APB will be equals to 180 degree. So you can see we are given a circle with center O and two tangents PA and PB from point P. So आप देख सकते हैं हमें दो टेंजेंट दिए गए हैं PA और PB, and we need to prove that angle AOB plus APB equals to 180 degree. So as radius is perpendicular to tangent at point of contact, therefore angle OAP equals to OBP. So OAP equals to OBP equals to 90 degree. दोनों एंगल क्या होंगे आपके 90 के होंगे. अब आप देख सकते हैं this is also of 90 degree, this is of 90 degree. So and this is AOBP is a quadrilateral. So by angle sum property we can find these two angles, sum of these two angles. So now in quadrilateral AOBP, by using angle sum property, AOB plus OBP plus BPA plus OAP equals to 360 degree. So now AOB plus OBP is 90 degree plus APB plus OAP is 90 degree equals to 360 degree. So AOB plus APB equals plus 180 equals to 360 degree, and AOP plus APB equals to 360 minus 180 equals to 180 degree. Means इन दो एंगल का सम कितना अभी 180 डिग्री है, and if the sum of two angles is equals to 180 degree means these two angles are supplementary to each other. So thus we can say angle AOB plus APB equals to 180 degree, or we can say AOB and APB are supplementary to each other, or we can say angle made by the two tangents is supplementary to the angles made by the line segment joining to the point of contact with the center. So this is all about question number 10. So now proceed for question number 11. In question number 11 we are to prove that parallelogram circumscribing a circle is rhombus. So हमें एक parallelogram given है जो क्या कर रहा है, circumscribed है to a circle, means parallelogram is outside the circle, touching the circle at 4 different points P, Q, R and S. You can see here. So we are having a parallelogram ABCD which touches the circle at 4 different points, that is P, Q, R and S. So from these 4 exterior points there are pair of tangents. So here point A is forming two tangents, that is AP and AS. Similarly here BP and BQ, and similarly here CQ and CR, and here DR and DS. So these are pair of tangents from exterior point to the circle. So therefore length of these tangents will be equal in measure. So we need to prove that ABCD is rhombus. So I am repeating again, we are given a parallelogram ABCD circumscribed to a circle. We need to prove ABCD is a rhombus. Now in the proof part, ABCD is a parallelogram, therefore first of all write the properties of parallelogram, that is opposite sides are equal and parallel. So we need to just equal sides. So AB equals to CD and BC equals to DA. So AB is equals to CD and BC is equals to DA. So now as the length of tangents drawn from external point to circle are equal measure, therefore we can say AP equals to AS, AP equals to AS here, and BP equals to BQ, CR equals to CQ, and DR equals to DS. Adding all the above equations we get AP plus BP plus CR plus DR on the left hand side, and on the right hand side we will get AS plus BQ plus CQ plus DS. So AP plus BP, you can see AP plus BP and CR plus DR, and here AS plus DS and BQ plus CQ. So now here AP plus BP become AB, CR plus DR become CD, and here this will be DA and this will be BC. But from equation 1, that is opposite side of parallelogram are equal, therefore AB equals to CD and BC equals to AD, or you can say DA. So now AB plus CD can be replaced with AB, so put here AB, and similarly DA plus BC can be replaced with, you can say DA. So twice of DA equals to twice of AB, or you can write twice of A B equals to twice of AD. So 2 will be cancelled here and AB will be equals to AD. So now adjacent side of parallelogram are equal, then we can say the parallelogram ABCD is rhombus. So here, as adjacent side of parallelogram are equal, therefore parallelogram ABCD is a rhombus. This is all about question number 11. So now proceed for question number 12. So a triangle ABC is drawn to circumscribe a circle of radius 4 cm such that segment BD and DC, into which the BC is divided by the point of contact D, are of length 8 cm and 6 cm respectively. Find side AB and AC. So you can see on the screen, we are given a circle with radius 4 cm and this point of contact divides the side BC in part BD, that is 8 cm, and CD has 6 cm. So we need to find side AB and AC. So now proceed for solution part. So here you can see we are given a triangle ABC that is circumscribed to a circle of radius 4 cm. So here radius OD, or you can say OE, and OF as equals to 4 cm. So let the circle touches the sides AB, AC at point E and F respectively. So here you can see. So join OA, we have to join OA, OB, OC, OE, OF. So इन सभी को join कर लीजिए. So OE join होगा तो हमें क्या मिलेगा? Radius is perpendicular to tangent, so here it will be formed right angle. Similarly, when OF is joined to side AC, so this will be a right angle. And similarly, OD we are already given that radius is perpendicular to tangent at point of contact. So also join OA, OB and OC. So now we have OD equals to OE equals to OF equals to 4 cm. That is the radius of circle. So you can see here OE, OD and OF will be equals to 4 cm. That is radius of circle. So now as the length of tangents drawn from external point to the circle are of equal measure, therefore this BE will be equals to BD, that is 8 cm. Similarly here CD will be equals to CF equals to 6 cm. And let us assume that AE equals to AF equals to X cm. So if we find X, then we can find side AB and similarly side AC. अगर हम X find out कर लेते हैं, so हम side find out कर सकते हैं AB और AC. As we already part B, so then we will add X to the 8, we will get side AB. And similarly जैसे हम X फाइंड आउट कर लेते हैं, हम AF भी फाइंड आउट कर सकते हैं क्योंकि हमें CF पहले से ही पता है. सो AF प्लस CF विल बी AC. सो नाउ प्रोसीड फॉर सॉल्यूशन. As we are given CD equals to CF equals to 6 cm and BD equals to BE equals to 8 cm. That is length of tangents drawn from exterior point to the circle are equal. So let AE equals to AF equals to X. So now in triangle ABC, we have side AB as X plus 8 cm, BC as 14 cm and AC as X plus 6 cm. So now find the semi-perimeter of triangle ABC, that is sum of sides of triangle, that is AB plus BC plus CA, that is perimeter. You can say perimeter upon 2, that is half of the perimeter is known as semi-perimeter. So here AB is as X plus 8, BC as 14 and AC as X plus 6 upon 2. So this will be 2x plus 28 upon 2, and this will be 2 into x plus 14 by 2, 2 will be cancelled. So x plus 14 cm is the semi-perimeter, means half of the perimeter. So S equals to x plus 14 cm. So now by using Heron's formula to find the area of triangle ABC, we will find the area of triangle ABC by using Heron formula as well as right angle triangle formula to find the value of x. So now area of triangle ABC will be under the root S into S minus A, S minus B and S minus C square unit. So under the root S, that is x plus 14, and S minus A, that is x plus 14 minus first side, that is minus x minus 8, as there is positive sound, negative sign outside the bracket. So this will be x plus 14 and here this is negative and x plus 8. Whenever we open the bracket, the sign of these two terms will be changed, become negative. So x plus 14 and become minus x minus 8 into x plus 14 minus 14, and here it is x plus 14 minus x minus 6. So now after simplifying, we will get under the root x plus 14 here, and here x will be cancelled. So 14 minus 8 becomes 6, and here 14 will be cancelled, it will be x, and here x will be cancelled, 14 minus 6 become 8. So now after simplifying, we will get 48x into x plus 14 under the root square centimeter as the area of triangle ABC. So now also we can find the area of triangle by using the area of three triangles, that is right angle triangles, area of AOB plus area of BOC plus area of AOC. Area of AOB, BOC and area of AOC will find by using the formula right angle triangle, that is 1 by 2 into base into height, and sum of these three triangles will be equals to area of triangle ABC. So area of triangle AOB will be 1 by 2 into base, that is AB, and height, that is radius OE. As we know that radius is perpendicular at the point of contact to the tangent. So here AB is tangent and OE is the radius. So AB will be as base and OE will be as perpendicular. So 1 by 2 into base into height. Similarly in triangle BOC, 1 by 2 into base BC, and radius will perform as perpendicular. So 1 by 2 into BC into OD. And similarly in triangle AOC, 1 by 2 into base will be AC and perpendicular will be OF. So put all the values here. 1 by 2 into AB is x plus 8, OA is 4, that is radius. Similarly here 1 by 2 into BC is 14 and OD is 4, and similarly here 1 by 2 into AC, that is x plus 6, and OF is 4. So after simplifying, you can see here we will get 4 into x plus 14 square centimeter as the area of triangle ABC. So now we have two relation of area of triangle ABC. Here it is 4 into x plus 14 centimeter square, and we already find that is area of triangle is under root 48x into x plus 14. So now equate this to relation. So from equation 1 and 2 we can say under root 48x into x plus 14 equals to 4 into x plus 14. So now on squaring both sides we will get 48x into x plus 14. Here square root will be cancelled, and on the right hand side 4 into x plus 14 whole square. So on squaring we will get 4 square becomes 16 and x plus 14 square. And here on the left hand side we have 48x into x plus 14. So now 48x, and transpose this 16 to the left hand side. This will be become in division. So 48x upon 16, and this will be here 3x, and this will be transposed to the right hand side, become x plus 14 square upon x plus 14. So this will be x plus 14. So now 3x equals to x plus 14, and x will be transposed to the left hand side, become 3x minus x equals to 14, and this will be 2x equals to 14. So now x will be 14 upon 2 equals to 7. So हमें x मिल जाता है 7. So here hence we can say side AB will be equals to BE plus AE, and BE we are already given, that is 8 centimeter. So AE will be 8 plus x equals to, that is 8 plus 7 equals to 15 centimeter. And similarly AC will be CF plus AF, and CF we have already given, that is 6. So AF we have x, so 6 plus 7 equals to 13 centimeter. Thus the side AB of triangle ABC equals to 15 centimeter, and side AC of triangle ABC equals to 13 centimeter. This is all about question number 12. So now question number 13. Prove that opposite side of quadrilateral circumscribing a circle subtend supplementary angle at the center of circle. So again the opposite sides of quadrilateral are circumscribing supplementary angles. So keep in mind, supplementary angles are those angles sum of which are equals to 180 degree. So sum of two angles when become 180 degree, then the angles will be called as supplementary angles. Keep in mind. So here in the quadrilateral ABCD, that is circumscribed to a circle with center O, we are given, and we need to prove that opposite side subtends supplementary angle at the center. So here you can see opposite sides means AB and CD are performing or making supplementary angle at the center, means we need to prove that angle 1 plus 2 plus 5 plus 6 equals to 180 degree, and similarly 3, 4 and 7, 8 are making supplementary angles at center. So means 3 plus 4 plus 7 plus 8 equals to 180 degree. So opposite sides are making supplementary angles. So we need to prove that AOB plus COD equals to 180 degree, and similarly BOC plus AOD equals to 180 degree. So now in two triangles we have to take any pair of triangles. So आप यहाँ ये पेयर ले सकते हैं, ये पेयर ले सकते हैं, ये पेयर ले सकते हैं, और ये पेयर ले सकते हैं, जो आपका मन करे. So देखिए in triangle AOP I am taking this one and this one. So in triangle AOP and AOS, so you can see on the screen. So AOP and AOS, so we have AOS common, that is common side to both triangles, and OP equals to OS, that is radii of congruent radii of circle, और you can say congruent radii of circle. So देखिए रेडियस क्या है, एक सर्कल की सभी congruent होती हैं एक दूसरे के साथ. So आप radii of same circle भी कह सकते हैं. So AO equals to common, OP equals to OS, that is radii of circle, and AP equals to AS, that is equal lengths of tangents, और आप कह सकते हैं equal tangents from extreme point to the circle, that is point A. So point A से जो आपके tangent draw किए गए हैं, that is AP and AS are equal in lengths. So AO equals to AO, OP equals to OS, and AP equals to AS. So two triangles have three sides as equal measure. So triangle AOP will be congruent to triangle AOS by side-side congruency criteria. These three sides of two triangles are equal in measure, therefore these two triangles are congruent to each other by side-side congruency criteria. Therefore we can say by CPCT angle 1 equals to angle 8, and CPCT means you all know corresponding parts of congruent triangle. So दो ट्रायंगल जब कॉन्ग्रुएंट हो चुकी है उनके रेस्ट सभी पार्ट्स के हैं इक्वल होते हैं. सो एंगल 1 इक्वल्स टू एंगल 8. सिमिलरली वी कैन प्रूव फॉर अदर ट्रायंगल्स दैट इज एंगल 2 इक्वल्स टू एंगल 3. सिमिलरली हम कह सकते हैं एंगल 2 और 3 क्या होगा, इन दो ट्रायंगल में इक्वल होंगे. सिमिलरली 4 इक्वल्स टू 5 एंड 6 इक्वल्स टू 7. सो नाउ एडिंग ऑल दिस angles, that is at a complete angle, or you can say at point O. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 equals to 360, as all the points, all angles are at point O. So this is complete angle. So now we are required to prove that opposite sides, means we need to prove 1 plus 2 plus 5 plus 6 equals to 180 degree. So replace rest of the angles. So 1 plus 2 we are required, but 3 will be replaced with 2. You can see here 3 को replace कर सकते हैं एंगल 2 से. Similarly 5 is required, so 5 plus 6. So 6 we are not required, 6 we are also required. So we can replace 4 with 5. So 4 will be replaced with 5. So 5 plus 5 and 6 plus 6 plus angle 1. 8 will be replaced with 1. So equals to 360. So now twice of angle 1 plus twice of angle 2 plus twice of angle 5 plus twice of angle 6 equals to 360. So now 2 can be taken as common. So 1 plus 2 plus 5 plus 6 equals to 360 degree. And now 1 plus 2 plus 5 plus 6 equals to 360 upon 2, that is 180. And 1 plus 2 can be written as angle AOB. And 5 plus 6 can be written as COD equals to 180 degree. This is the part we are to prove. Similarly, we can say opposite side, that is BC and AD, will perform same function and will form supplementary angle at the center. So we can say similarly BOC plus AOD equals to 180 degree. And this is all about question number 13. So if you learn from this video, then please do subscribe my channel and share this video as much as you can. Thanks for watching.